Welcome to WOW TV. My name is Angel, and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today you're going to review what you've already learned about Sir Isaac Newton and then explore his third law of motion. Are you ready to get started? Let's go! Let's start by reviewing what you've already learned about Newton's first and second laws of motion. The first law says that an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same direction and speed. This law is often called the law of inertia. This means that there is a natural tendency of objects to keep on doing what they're doing. All objects resist changes in their state of motion. In the absence of an unbalanced force, an object in motion will maintain this state of motion. The second law says that the greater the mass of an object, the more force it will take to accelerate that object. This also means that the harder you kick a ball, the farther it will go. It is best stated in an equation that relates an object's mass and acceleration to the amount of force involved to cause motion. Force equals mass times acceleration. Today we will focus on the third law. It states that for every action, there is an equal and opposite reaction. Let's think about that action as a force. In other words, if object A exerts a force on object B, then object B also exerts an equal force on object A. Think of it as an action and a consequence. The second action happens because the first action caused it. Using the idea that for every action there's an equal and opposite reaction, let's think about how rocket engines work. As rocket engines are lit, they produce a downward thrust, which results in the upward direction of the rocket launch. If a rocket shoots particles in one direction, the rocket travels in the opposite direction. The action caused the reaction. Let's think about a simple action-reaction experiment you've probably all had the experience with already. When you blow up a balloon, you are filling it up with air that is under pressure. When the air escapes from the balloon, or when you let go of it, the escaping air exerts thrust or force on the balloon, which propels it forward. The air escapes backward, and the balloon races forward. There's an action, and then a reaction, or more formally known as Newton's third law of motion. Let's jump into an activity to show you what I've been talking about. Teachers, I'll need you to choose 2 volunteers for our first demonstration. Have the first student sit on the scooter with their feet pulled up and out of the way. Hand that student a toning ball. That student should toss the toning ball to student number 2. Allow them to play catch for a moment. I'll wait here while you do this. Let's talk about what just happened. The student sitting on the scooter tossed the toning ball to their partner, causing the scooter and that student to move backwards in the opposite direction. The harder the toning ball is thrown, the farther and faster the scooter and the student should travel in the opposite direction. Every throw and catch should have moved the student on the scooter backwards, showing every action has an equal and opposite reaction. I'll wait if you want to give more students a turn at proving that every action has an equal and opposite reaction. Let's compare what we just saw to what we discussed with rockets. Consider that in our activity, the student on the scooter was the rocket and the toning ball was the engine. Can you explain that? Think for a moment. What was the reaction? Did you say it was the student moving backwards? Now, what caused that to happen? Did you say the action was the force or the exertion of the ball? Can you use what you know about Newton's second law to explain that? The reaction, the acceleration, is based on the force of the throw. Sometimes there's confusion between Newton's second and third law. Let me give you an example that might help make things clearer. When a boxer punches an opponent and the opponent flies backwards, there is an action and a reaction. I'm going to give you a minute to discuss this with your class. Why is this an example of Newton's second law and not his third? Okay, back to our boxer. When a boxer punches an opponent and the opponent flies backwards, there is an action and a reaction. But the action and reaction are not opposites. Remember, the law says that for every action, there is an equal and opposite reaction. The punch, the action, is in the same direction as a staggering opponent, the reaction. It is Newton's second law because the acceleration of the object, the staggering opponent, is in the same direction as the force, the punch. Let's move on to our main activity. You're going to be working in groups to construct rocket racers. After building your rocket racer, your class will conduct trials to see how far your racer can go. Your teacher has all of the materials, the activity sheets and directions, and the templates or patterns you're going to need. Teachers, after the groups have begun to build their racers, you can prep the room. We need a smooth area of the floor. Stretch out a straight 10-meter long line of masking tape and make a mark at 10-centimeter intervals. This will help students calculate their distance quickly. I'll meet you back here after the racers are built so I can give you directions on the races. Okay, are you ready to race? 2 student groups at a time will line up their racers at the start line. You'll fill up your balloons using a balloon pump. Groups should use the same number of pumps. Your teacher can make the decision to determine how many pumps it takes to adequately fill the balloons. Make sure to measure and record the distance your racer travels. Remember, you're a team. Please take turns pumping, measuring, and recording. Each team will complete 3 trials and have the option to modify their racer to improve performance between each trial. I'll meet you back here when all of your trials are completed. Enjoy! So how did that go? I want to give you a few minutes for groups to share their rocket racer and the results. We'll pause here as you discuss these questions. Okay, I want to show you something, but I do have a favor to ask. If you've already seen one of these in action, please let those seeing it for the first time have the opportunity to figure it out. This is called a Newton's cradle. When we're finished, I hope you can explain why this is an example of Newton's third law of motion. I'm going to raise one and release it. You see that? What was the action? What was the reaction? Let's watch it again. When I raise the one, that's the action. Then when I release it, the reaction. The collision sends one away from the center. Did you see that the action caused the reaction? Now, let's make a prediction. What will happen if I use 2? Is that the result you predicted? Now, how about 3? What will happen since there are only 2 that could be involved in the reaction? Ready? Let's pause for a moment so your teacher can lead a discussion about what happened, why, and why this proves Newton's third law. I'll meet you back here in a few. Since you've now studied all 3 of Newton's laws, let's use all 3 as we explain the simple act of walking. Before you start walking, you are an object at rest that needs a force to become an object in motion. Pushing on the floor with your foot would be that force. Once in motion, a force is required to stop walking, such as gravity or friction. That's Newton's first law. Now, your forward motion, also called acceleration, is based upon how hard you're pushing with your foot on the ground, that's the force, and how much you weigh, that's the mass. The harder you push, the faster you go. If you were to pick another student up while you were walking, you would need to push harder on the ground with your foot if you wanted to maintain your current speed. Otherwise, you would slow down. That's Newton's second law. When you push against the ground with your back foot, an opposite reaction of you moving forward is produced. Your forward speed is directly related to how hard your foot pushes. That's Newton's third law. Since you have become experts on Sir Isaac Newton, let's do one more activity in honor of his studies and teachings on gravity. Every item has a center of gravity. Every person has a center of gravity as well. Simply put, the center of gravity is the determining factor in balance. If the center of gravity is in balance, then so is the object. However, if the center of gravity is thrown off balance, then the object will either be supported or will topple. When there are opposing forces to an object, if they are equal and opposite, the object will balance. Your teacher is going to give each group a sheet of directions and a balancing nails kit. The object is to balance all of these nails on the head of a single nail. All of the nails have to be balanced at the same time and cannot touch anything but the top of the nail that's stuck in the base. You think you can do that? Go ahead and give it a try. I'll meet you back here in a few. How about that? Did you get it? That is so cool. You all did a great job today. Thanks for joining me. Teachers, thanks so much for using this WOW lesson, and please check out more at our website at wpafbstem.com.